We're back. This unit is all about inheritance. In our last video, we talked about the difference between has-a and is-a relationships and kind of got introduced to inheritance, right? So has-a relationships are represented via instance variables, right? We would say something like a student has an ID, a student has a GPA, and again, those are instance variables within the student class. But with object-oriented programming, we also want to represent is-a relationships, right? Student is a person. So we learned that this can actually be established in Java using the extends reserved word. What we're going to do is ultimately tag what we know as a subclass with extends, right? We say student extends person. This creates a class hierarchy, which student is the subclass, person is the superclass. And we learned there's a lot of stuff that goes along with this. For one thing, a class can have only one subclass. I'm sorry, let me rephrase that. A class can only have one superclass. The superclass of student is person, period. However, you can have multiple subclasses, right? This is still true. We see that student, the only superclass is person. Employee, the superclass is person. However, person has multiple subclasses, but note this arrow kind of denotes the flow. Student is extending person, and we actually see that in the header. Maybe this is a better example here, right? Student extends person. So student is the one doing the extending. Person, if you look, actually has no reference to student at all. So it actually has no idea what its subclasses are. Okay. Now, this exists for multiple reasons. One is to kind of represent stuff in the real world, right? We're talking object-oriented programming here. We want to represent the real world as much as possible, and student is a type of person. But there's other class hierarchies out there, right? I talked about how a rectangle is a shape, a lamp is a light, a laptop is a computer. Right, so there's categories out there, and this is ultimately what we're representing. The other thing is going to be that we're going to actually have some programming benefits, right? The subclasses are going to be inheriting things. Properties, such as our instance variables, are going to be inherited, meaning that our subclasses are going to have a copy of those instance variables in addition to the ones that they define. But also those behaviors are going to be inherited, right? We ended up doing some coding and kind of showing this off. All right, let's keep in mind that a person has a first and last name. We have a no-args constructor that gives it a first and last name of Bob Jones, but we also have this constructor here, which will give it a first and last name that we specify. So I can person equals new person, Jones Bob. This is not confusing at all, right? And I can sout on that person because we wrote a toString. So person has a first and last name. If you look at student, student is extending person. That establishes our class hierarchy. It is going to inherit the first and last instance variables. So it will have a copy of those. In addition, student is adding 2 instance variables to that, an ID and a GPA. So in total, a student has 4 instance variables. This gets tricky, however, because student doesn't have direct access to them. They are private, and as I explained in our last video, you want to make sure they are private. The AP exam will take points off if instance variables are not private. In practice, outside of the AP course, you could consider using other access modifiers, which I won't even mention here because I don't want you using them. But because they're private, the access is restricted to the class. So even though student gets a copy of these things, a student will have a first and last name, it can't directly access and modify them. That's not a super big problem because ultimately what we're going to do is make calls to things like the superclass constructor. Okay, so I'm going to make a no-arg student. And then we're going to print off our student. In fact, I'll comment this out so that we'll see. Do we have a student with the name Sarah? Sarah. Take a look at this flow. Right here, I'm calling the noargs constructor. That's going to come into here. First thing it does, it calls super. What I'm doing here is calling the superclass constructor. Notice I said the superclass constructor and not a superclass constructor. You can only have one superclass. Keep that in mind. Okay, the superclass of student is person. So it's going to go into person looking for a signature, a constructor that has 2 strings as parameters. So that means we're going to be executing this. What does that do? It takes in that string, which it'll call first. It takes in the other string, which it'll call last. And it saves first into this dot first. It saves last into this dot last. So this is actually initializing the first and last name for the student. Keep in mind what I printed here. It wasn't a person. It was a student. So what I'm proving is that student does have a first and last name. They are inherited. In addition, student is going to basically tack on the ID and GPA. Those were additional instance variables, right? In the toString that you see here, right? Keep in mind we are implicitly calling student.toString. This seems a little weird because if we take a look back at our student, we actually don't have a toString method. So where's this coming from? Well, it was actually defined in person, right? So student is going to be inheriting this toString. This gets interesting again because it is referencing first and last, which in theory student does not have direct access to. So we are inheriting the toString that is defined in person, meaning that student can do that. There's other methods that get inherited. For instance, get first. That is a method defined here in my person class. However, look what I'm invoking it on. This is a student. It's not a person. We inherited this. So that is the, excuse me, that is the programming benefit of this. We ultimately get to reduce code, duplicate code. A person has a first and last name. A first and last name is also something that a student would have. Instead of writing it in person and then turning around and basically duplicating it in student, I wrote it in one place and we are inheriting it. On top of that, we're able to represent a class hierarchy, right? A student is a type of person. Kind of cool. So there is basically abstract reasons to do this. We get to have our class hierarchy. There's also the programming syntax benefits that we have by reducing duplicate code. Okay. Now, that's where we're going to kind of pick up today because this is the toString of student, but realities are I got this ID and GPA that I want to be incorporated into my toString. So, seems easy enough. We're going to go public string toString. I'm going to write a toString method. Now, this is where things get interesting. I already have a toString method in student. I'm not talking about the one that I'm defining right now. I'm talking about the one that I'm inheriting. There's already a toString here. Okay. What I'm actually doing here is overriding the method. As we learned in the previous lecture, any methods defined in the superclass will be inherited by the subclass, right? We have this getName method. Ours is like get first or get last, but I kind of do recommend writing a getName that is the combination of both. Whatever methods are defined here in person, student's going to get them as well. So in addition to this stuff, student is also going to have things like get first, get last, getName. In this example, the student will inherit the getName method, meaning a student object will be able to call the getName method, right? We've seen that. We've seen that in IntelliJ, where if I take my student object and I tell it to invoke a method, I see a list of methods it can call, including get first, get last. Okay. In some instances, a subclass may want to redefine a superclass method in order to change the method's functionality. The toString is the perfect example of this. The toString that we're inheriting right now in student only does the name, but I got more stuff. Person's toString method should return a string representation of the person object. Sure. Student will likely also want a toString method, but the toString inherited from person returns a string representation of the person object, not a student. The string representation I'm getting now is limited. It's only stuff pertaining to student, or it's only stuff pertaining to person, and I need it to have stuff pertaining to student. The solution, student should override the toString method inherited from the person class. So we've talked about overloading before. Overloading is when we have methods in the same class with the same name but differing parameters. All right? Think about some string methods that we have looked at. Substring was an overloaded method. Index of was an overloaded method. Okay. This is similar, slightly different. It is overriding. Method overriding occurs when a subclass defines a method with the same signature, that is, the same name, the exact same parameters, the exact same return type as the method defined in its superclass. Okay, what am I saying? Take a look here. Person is defining get name, get first, get last, whatever you want to call it. Person also has a toString. Yep, we did that. If you take a look here, we're adding on ID, we're adding on GPA, but we're going to override the toString method. This has the exact same signature, the same name, toString, the same parameters, nothing, the same return type, string. Return type matters less, right? Because think about this. Ultimately, we have to call this method. The thing with overloading, the reason why there had to be different parameters when we're talking about overloading is because you had to distinguish which version you wanted to call. Here we're saying, I don't care about this version anymore. I want my own version. So the signatures can match in this case. We don't care about the return type. Okay, so I'm going to override the method. Here I am in student. I got the same signature, right? Same signature. By that, we're talking same name, same parameters. So I am ultimately going to replace what we were doing with the person class. Okay. Ultimately, this needs to be a string representation of my object. That is, I need all the stuff pertaining to my instance variables. How many instance variables does a student have? If you say 2, no. We have 4 total, right? We have these 2 that you see right here, but we also have the 2 that we're going to inherit. So a student actually has 4 instance variables, right? So whenever we're talking about a string representation, I want the first name of my student. So first. Right away you see IntelliJ is bad, right? We talked about this in our last video. If I scroll over this, this is private. Even though student has a copy, this is private. Private, as I've said multiple times, and I've been very clear in my word choice, private restricts access to the class that it is defined in. What that means is that even though student has a copy of this, we can't directly access this instance variable. What we can do is use any methods that may have access. One such method is get first. Right? Here I am in the student class. We are inheriting methods from person. One of those methods is a getter, an accessor method. So instead of me accessing it directly, I'm going to use a method which I do have access to. It's one that we've inherited. So we're going to call get first. That's the one that we've inherited. We'll go in here. We'll get the first name. Right? Now we're asking the person class to give it to us as opposed to just barging in and getting it directly. So I'm going to tack on my first name. I'm going to do a new line. We'll do the last name along with our get last in a new line. And this is where I'm getting to the stuff that is specific to person. I'm sorry, specific to student and ID. So I'll say maybe ID. Because this instance variable is in this class, I have direct access. So I don't have to go through an accessor method here. And then lastly, our GPA. Okay. So we are overriding the toString method. I did inherit a toString. We see it down here. It's not good enough. I want to override it. I'm going to replace it by writing a method with the exact same signature, same name, same parameters. Also, technically, same access level or similar access level, something like that. So I'm back in my class. We are making a student using the noargs constructor, and then I'm going to print it off. And there we see it. Our first and last name, which we're using accessor methods in order to get, as well as our student-specific instance variables. Okay, I'm going to take a moment to talk about the @override tag. Now that we know what overriding is, something of note, something that we could have done is alt insert a toString. When we do this, it's going to ask what instance variables do you want to involve. Interesting, it didn't give me the other two. But take a look. For one thing, I don't really like the formatting here, which is why we didn't go this route, but it included an @override tag. You may see this if you alt insert some code. And I get this question asked quite often. You know, what is this? What does this even mean? We call these tags an annotation. It is an optional tag that indicates that a method intends to override a superclass method. @override makes overriding a compile time issue. That is, the signature of the method tagged with @override must match the signature of a superclass method, or else the program won't even compile. Let me show you what I'm talking about. I'm going to take this toString back out. I'm going to tag this with @override. I don't have to. Notice that I did it. Right? We successfully overrode and never actually tagged it with @override. I should, of course, note that this is outside the AP subset, so you don't necessarily need to know this. Okay, so I am saying that this method is intending to override an existing method, and we are. We inherited a toString method from person, and this method is overriding that. Okay. This turns it into a compile time issue, because now, if I come in here and say that maybe we take in a Boolean, notice that IntelliJ underlines this bad boy. This is a syntax error. Okay, we're detecting it essentially at compile time before I've executed the program. Notice this is gray. That's because it's not being called, right? What I am doing currently is not overriding the toString method. I am overloading the toString method, right? Because we have the toString that we've inherited that has this signature. I have this toString, which is overloading. It's got the same name. In theory, it's in the same class because we have inherited the one from the superclass. But the signature is different. We're taking in a parameter here, so that doesn't quite match. However, I said, oh, I intend to override, but I'm not. That's what this is. It's an optional tag. What do I mean? If I were to delete it, everything's happy because I'm technically overloading at this moment, right? If I were to run my program again, which is calling a toString that doesn't take in any arguments, we get this, right? We get just the first and last name. That's the one that we've inherited from person. Right? In order to see the other toString, I would have to call it passing in this stupid little nonsense Boolean. In order for that to work. I am overloading right now, not overriding. Okay. So @override, it's for your benefit, right? You're just like, I plan on overriding. The reason why this is relevant is in this moment, I can't technically see the person toString, right? I have to flip back to it to see it. Okay. Well, imagine your class is like forever long. It's huge. Maybe it's one that you don't necessarily, it's not one that you've necessarily written. And so you're not positive what the signature is. You just know you need to override. Okay. So you could tag your method with @override and it makes it a compile time issue. All right. So we can put it on. We can leave it off. We are successfully overriding. What is this related problem? Oh, yeah, this method doesn't exist anymore. Thank you. IntelliJ, you smart. So that is one that you will see from time to time, particularly if you alt insert some code, you might see it. It's outside the subset though. When overriding methods, the subclass will likely need to access or modify the instance variables inherited from the superclass. So that we saw that here, right, where I wanted to access first, I wanted to access last. This could potentially be an issue as those instance variables are likely private. Our student tostring, for example, should include first and last. However, these instance variables were made private in the person superclass. Fortunately, student also inherited the means to access and modify these instance variables, as student also inherited the getters and setters. Okay, so instead of our student, we had our ID and our GPA, but we also want to include information about our name. I can't access those values directly because they are private. I can, however, use the methods that we've inherited, which have public access. So we did that. Now, here's where some things get a little interesting. Because occasionally a subclass may still need to use a method defined in the superclass, even though the subclass has already overridden it. What do I mean? We just overrode the tostring method. At this moment, student only has one tostring, right? Here, when I say student.tostring, there's only one. The one that we inherited from person, we overrode it. Student doesn't have this one anymore. What our slides is saying is that sometimes you may still want to refer to that particular one. I'll actually show you a good reason why you'd want to do it here in just a moment. That's where the super dot notation comes in. It can be used to explicitly call a method defined in a superclass. So this is going to feel similar to a couple of things. For one thing, it's going to feel similar to the super constructor call. Right? Here we're calling a constructor coming from the superclass. The other thing it feels similar to is this dot notation. Right? When I say this dot, I'm talking about in this class. In this class, go find first. More specifically, it means this object. But go find first inside of this. What our slides is introducing us to is super dot, which says go into the superclass and look for the thing. Okay? Why is that important? Well, things like get first, get last, we're inheriting those in our student. That's fine. I still have access to those, right? I can still call get first and get last. What I can no longer call is the tostring, right? If at some point in my code I call tostring, the tostring I'm calling is this one, right? IntelliJ is even highlighting this, saying this is basically like a circular reference, right? This is going to call itself indefinitely. This is the same thing as saying this dot tostring. There's only one tostring in student, and it's this one. So whenever I call tostring, first thing it does is it's going to call tostring, which is going to call tostring, which is going to call tostring, right? So this is infinite recursion. We'll learn about recursion later. But I sometimes want to refer to the superclass tostring, okay? Why might that be? Well, take a look at what the superclass tostring does. It gives me the first and last name. I have effectively duplicate code here. Here's the first and last name. Here's the first and last name. So one cheeky kind of clever thing we can do is instead of doing this, which is ultimately duplicate code, we can say super.tostring. And then I'm going to tack on a new line. Let's see what this does. I'm in student, and I'm going to call the tostring method. Right? We constructed a student using the noargs constructor, and then we print it off. I'm getting all my values. Let's take a look at the flow of this. Right here is an implicit call to student.tostring. So let's go to student. Here's the tostring method. It says super.tostring. So I'm going to go to the superclass of student. The superclass of student is person. This is going to create this string consisting of the first and last name and return it. It returns it to this spot right here. I'm going to take that string, add to it a new line. So far, that's produced this bit that I've highlighted. We then are going to tack on our ID and GPA, and that gets returned. Okay, so occasionally a subclass may still need or want to use a method defined in a superclass, even though we have already overridden it. And that is where super dot notation comes in, because we can explicitly call a method defined in the superclass. So, yep, we basically went through this. We have our persons tostring, which is doing a first and last name. That returns it to student, and then student ultimately uses it. We've already demonstrated all this. That is actually going to be a good spot for us to pause. I'll put the last little bit of code up, and I'll see you in the next one.